Next is goodness of fit test, and we'll be looking at two different goodness of fits. One is multinomial probability distribution and the other is normal probability distribution. In each of these cases, we'll have the observed frequencies and the expected frequencies if the probability distribution is the multinomial distribution or if the probability distribution is the normal distribution. So once you have the observed frequencies and the expected frequencies, then we can compute the chi-squared like we have done in the previous examples. Okay, first let's take multinomial. What is multinomial? Multinomial is a case where we have several possibilities and each possibility has a probability associated with that, or in other words, we can in general terms we can call this a discrete distribution. Okay, one example here will be let's look at a couple of examples or two or three. So suppose we have a class where we have students receiving A, B, C, D, or F. Now suppose if we say that there are 30% A's, 40% B's, and 20% C's, and so on, then is that true? We can then collect a sample and then see whether the observed frequencies and the expected frequency, if the probabilities we assumed are true, and then we can do the test. And also opinion survey, opinion about a political party or opinion about a candidate or opinion about a product. So whether you oppose it, whether you favor it, whether you oppose it, or you don't know, you don't care, or strongly favor, moderately favor, strongly oppose, moderately oppose, and don't care, or there could be a particular aspect and there are several possibilities to answer that question. Then what is the probability for each of those? Okay. So member of a political party is again another example where you have Democrat, Republican, or Independent. You can even divide the independents into more categories if you like, and you assign probabilities for each of them, or you want to test whether those probabilities are true. So our null hypothesis here is, once again, this is the only way in which we can set up the hypothesis in goodness of fit, that the given probability distribution is valid. So we have probability for each possibility, and we need to make sure that these probabilities sum to 1, because that's how it is a probability distribution. Okay. And the alternative is no, that assumed probability distribution is not true. Then we have the probabilities and the sample size. Okay, here is the observed frequency. Now if you take the sample size and multiply by each probability, so n times the first probability, n times the second probability, and so on, you get the expected frequency. So you have the observed frequency, expected frequency, and the rest is exactly like what we have seen before. Okay. Now the degrees of freedom here is k minus 1 in this case because we did not compute anything from the sample itself. So how many populations are there? Minus 1. That is the degrees of freedom.